In this video, we're going to look at a piecewise function and how to graph it when we have some different kinds of pieces going on here. So we have g of x equals the function, and I have a big brace here. So that indicates that these all go together and make up one function. But we have to graph the pieces separately, or if we were using software, we would type them in separately. So I have absolute value of x, but it's only in this domain x less than -3. X cubed is within the domain given as -2 less than or equal to x less than or equal to 2. So that's going to be in this section there. And then I end with 2x minus 4 for x is greater than 2. So if I were just graphing an absolute value function, I would do a V, because that's what it looks like. You'll get to know the parent functions after a while, but if you didn't, you would plot points. And on this one, I only want the section that's where x is greater than -3, so I would have to put a circle and then plot my line and get rid of the rest of these dashes. But that's what the whole function would look like. So you can do that and then erase, or kind of get the shape and only darken in that one piece there in the domain. But if you weren't familiar with parent functions, this one's the absolute value function. So I would just pick an x. So if x were -3, and it's not an undefined situation, I know it's really not equal to anything there. I can't touch it, so I have to put the open circle. But that would equal a +3. If I have -4 for x, I would get a +4, and so on and so forth, up until I would get positive infinity, and my x's would go down to -infinity. So if I am done with that segment there, then I just leave it, or that section, for my piece. Now I'm going to look at this piece here, the x cubed, and I know that shape is generally like this, right? That will fit the values, and if you weren't familiar with that, you could just plug numbers in. So we know it's going to have an x that's equal to -2, and I can cube that, and I would get -8. So kind of got to go down on my chart a little here, 6, 7, 8. And then I also know if I put in -1, I would get -1. So I have -1 cubed, and that's going to be a point right about here. And this is a solid dot down the bottom. This one we don't really want to make a big dot on the, especially if we're using software. We just need to know how to get our shape. For the next one, I would do 0 cubed is 0, and then I would have 1 cubed is 1, and 2 cubed is 8. So that again would be kind of up here, 6, 7, 8, and I would put a solid dot there because I know there's going to be a spacing issue. So I'm going to now connect my dots, and again, it doesn't have to be perfect if you're doing it on paper. A lot of times we use technology, and my dot here is a little off. Fix that. Okay, because that really should be a hard time getting that in the right spot, but it really should not go past the 2 there. Okay. Then we have our last one is a linear function. It starts, I'll just put it in orange, -4. If I wanted to kind of think, okay, that's my y-intercept, and I want to do slope-intercept graphing, you can do that. You just aren't really going to mark down or darken in anything until you get over in your domain that you need. So I would have -4 as my x-intercept, then I would go up 2 over 1 for my slope, up 2 over 1, up 2 over 1. Did I hit my, okay, and there's my 2 there. So I'm here, I go up 2 over 1, up 2 over 1. So I'm going to make that dot, but it's not included, right? So I need to have an open circle. And then I can go ahead and finish that line out, and it extends to positive infinity for both my domain and range. And there's a break in the graph, so I would actually, even on the electronic homework, I would plot that open circle in there. I think I should do in another video. If they actually connect, you would just leave it as one line, one smooth shape, I guess. You wouldn't put the dots all in there as I am doing here because there's breaks. And then I want to make sure I get rid of all these. Another way to do that is you could just pick a point. So I'm going to pick x is equal to 2. So that would come out to be 4 minus 4 is 0. So that's this point here. Again, open circle. You got to kind of keep in mind what the domain is as you're working. And then if I did 3, I get 6 minus 4 is 2, which is what I have here, and so on and so forth. So that's really all there is to it, other than the last piece would be kind of putting your domain together in your range. So if I look at my graph, I would have my domain would be negative infinity. I'm going to write it in interval notation to start with. So negative infinity up to negative 3, but not including the negative 3 because this dot is down here is actually not until negative 2. So we got to be careful of that so it doesn't connect. So then I would go union bracket negative 2 up to 2, but then also, even though this is an open dot, it actually kind of, the solid overrides, so I don't have a break there. I go right up to, I have a break in the spacing in the graph, but in my domain, my x values are continuous from negative 2 to infinity. So there's a little bit difference there. When we talk about breaks, we're talking about like having this space, so we definitely have to put our solid dot in because they're not touching. But here, my domain, my x's, went right on through, and they'll continue on to positive infinity. So with the range, I'll look at the up-down kind of situation, and I have, let's see what I have for any kind of breaks. So track it with this. So I come from, my highest one is positive infinity, and my lowest is really, because this domain is set there for my cubic, and I don't have anything below that, and this stops, and this stops. So my lowest is going to be this negative 8. But then, and it's included, so I do a bracket, but it goes all the way up onto infinity. And we never bound infinity, you just put a parentheses. So I hope that helps you with a little bit wrapping your brain around like the way the shapes go, and especially the domain and range. I think that's sometimes a little bit confusing, like if you have to split this apart or not. But if you were to split it apart, then you would notice that they would be continuous really within that interval. And you could put it all in the set notation, but we already kind of have that there. So hope you found that helpful, and have a great day.